Hi students, welcome back to Universal Chemistry channel. My name is Veerababu. Students, in our previous classes we started mole concept. We continue the topic. Okay. In previous class I said that carbon 12 has been taken as a reference. Why should carbon 12 isotope taken as reference? Okay. There are few reasons. Reason number 1, the availability of carbon 12 is easy. Availability of carbon 12 isotope is easy. This is the first reason. And reason number 2, carbon 12 isotope is not very reactive, as well as it is not inert. Inert means chemically inactive. Okay, it is not inert. And also last reason is 1 by 12th part of mass of carbon 12 isotope almost equal to mass of lightest element, mass of lightest element, that is hydrogen atom, that is hydrogen atom. That's why we should take carbon 12 isotope as a reference now. Okay, so these are the reasons. First one, availability of carbon 12 isotope is very easy. Second one, carbon 12 isotope is not very reactive. And third one, carbon 12 isotope is not inert. As well as 1 by 12th part of mass of carbon 12 isotope is called as 1 am, that is almost equal to mass of lightest element, that is nothing but of carbon. That's why carbon 12 isotope is taken as a reference in a mole concept. Okay, and next one, we continue. Next term, relative atomic mass or atomic mass. Relative atomic mass or atomic mass. Okay, next one, relative atomic mass. Atomic mass or atomic mass. Okay, students, relative atomic mass means actually it is a number. It is defined as number. It is defined as a number which represent how many times the mass of one atom of an element heavier than 1 by 12th part of mass of carbon 12 isotope, that is considered as a relative atomic mass or atomic mass. Dear students, you must remember that in chemistry mass equal to weight. Okay, what is the formula to calculate mass? What is the relation between mass and weight? Weight is equal to mass into gravity. Okay, in chemistry we mainly discussed about atoms and molecules. Okay, its gravity is negligible. That's why in chemistry gravity is taken as 1. Okay, so weight is equal to mass. Okay, that's why in sometimes we should use the term mass, in sometimes we should use the term weight. Both are same in chemistry. In physics, that is different, but in chemistry weight equal to mass. That's why we should use atomic mass or atomic weight, both are same. Okay, so this is about relative as atomic mass or atomic mass. Okay, let's another term, gram atomic mass or gram atomic weight. Gram atomic mass or gram atomic weight. Gram atomic mass or gram atomic weight. So listen carefully, children. If atomic mass is expressed in grams, if atomic mass is expressed in grams, that is called as gram atomic mass or gram atomic weight, or it is also defined as the mass of Avogadro number of Avogadro number of atoms. The mass of Avogadro number of atoms is called gram atomic mass or gram atomic weight. Okay, what is the definition for gram atomic mass? If atomic mass is expressed in grams, or the mass of Avogadro number of atoms is called as gram atomic mass. What is Avogadro number? Avogadro's number simply represented as Na. Its value is 6.022 into 10 power 23. In sometimes it is also taken as 6.023 into 10 power 23. So this much number of atoms mass is called as gram atomic mass or gram atom. It is also called as gram atom. Understood, students? Okay, note it. Okay, and next term is molecular mass. Molecular mass. Molecular mass or relative molecular mass. Okay, children. So it is defined as the number. It is defined as the number which represents which represents how many times the mass of one molecule of a substance, the mass of one molecule of a substance heavier than 1/12th part of mass of carbon 12 isotope, that is called as molecular mass. Once again I am repeating, molecular mass is defined as the number which represents how many times the mass of one molecule of a substance heavier than 1/12th part of mass of carbon 12 isotope, or it is also defined as the sum of atomic masses of all atoms present in a molecule. It is also defined as molecular mass. Okay na children, note it first. Next one, gram molecular mass. Gram molecular mass, or it is also called as molar mass. Gram molecular mass. Gram molecular mass are also called as molar mass. Are also called as molar mass. It is simply defined as the mass of it is simply defined as if molecular mass if molecular mass expressed in grams, if molecular mass expressed in grams, that is considered as gram molecular mass or molar mass. It is also defined as the mass of the mass of Avogadro's number of the mass of Avogadro's number of molecules. The mass of Avogadro number of the mass of Avogadro number of molecules is also called as gram molecular mass or molar mass. Okay, I have already told to you Avogadro's number is simply denoted as Na. It is equal to 6.022 into 10 power 23. Okay, it is also shown with 6.023 into 10 power 23. Okay, so this is called as gram molecular mass or molar mass. Okay, next, actual mass. Actual mass. Actual mass. Okay, so it is defined as the mass of one atom or one molecule. Okay, the mass of one atom or one molecule is called actual mass. Okay, next one average mass. Average mass. Okay, this average mass is used to calculate mass of isotopes. It is used to calculate mass of isotopes. Okay, so it is used to mass of isotopes. For example, an element has three isotopes. Okay, an element has three isotopes. Okay, so there are three isotopes for an element. Okay, its masses are considered as m1, m2 and m3. Okay, if their abundance is given in percentage, their percentages are considered as x1, x2, x3. Okay, if an element has three isotopes, their masses are taken as m1, m2, m3, and the abundance of isotope 1 is x1, isotope 2 is x2, isotope 3 is x3. So now the average mass is equal to m1 x1 plus m2 x2 plus m3 x3 divided by x1 plus x2 plus x3. So this is the formula to calculate average mass when abundance of isotopes given in percentage. Okay, so this is the formula to calculate average mass. Okay, note it first. We will see an example. Okay, so for example, For example, chlorine. If for example, chlorine, it has two isotopes. Chlorine has two isotopes. They are chlorine 35, chlorine 37. Chlorine 35 percentage, I mean its abundance is 75 percentage, and chlorine 37 abundance is 25 percentage. Let's we calculate its average atomic mass. Okay, so what is the formula? Average mass is equal to, here only two isotopes is there na, its formula is m1x1 plus m2x2 divided by x1 plus x2. Okay, so here m1 is 35, x1 is 75 percentage, m2 is 37, x2 is 25 percentage. Okay, let's we substitute these values. M1 is 35 into x1 is 75 percentage. Okay, take it as 75 in plus m2, mass of second isotope is 37 into its abundant is 25 percentage divided by 75 plus 25, that equal to 100. So 35 into 75 plus 37 into 25 divided by 75 plus 25, that equal to 100. Okay, so when we multiply 35 with 75, it gives 2625 plus 37, when we multiply 37 with 25, it gives 925 divided by 75 plus 25, 100, that equal to 3550 by 100. Okay, so finally we get to 35.5. Okay, so here average mass of chlorine is 35.5. That's why when we when we writing atomic mass of chlorine is okay na 35.5, it gives decimal value due to its average mass. Okay, most of the cases we should take whole number, but in case of some elements like chlorine we should take 35.5 due to this reason. Okay, chlorine has two isotopes. Okay, one is 35, chlorine 35, another one is chlorine 37, and its abundances are 75 percentage and 25 percentage. So it is one method. Okay, let's we see first of all, note it first. Let's we see second method. Okay, if fractions are given, okay, if abundance of elements given in fractions, in that case, second formula, when fractions are given, average mass equal to, okay, m1 f1 plus m2 f2 plus m3 f3 plus and so on divided by 1. Okay, so this is the formula when fractions are given. Understood? So here m1 is mass of isotope 1, m2 mass of isotope 2, and m3 is mass of isotope 3. Here f1, f2, f3 are fractions of isotope 1, fraction of isotope 2, fraction of isotope 3 respectively. Understood, children? So this is second formula to calculate average mass. Okay, so note it first, and let's we entered into very important topic, that is nothing but of mole. Okay na students? So now let's we discuss about definition for mole. Mole is an very important term in mole concept. What is mole? So it is a unit. It is used to calculate quantity of substance in chemistry. Already we discussed at introduction part. Okay, now the definition for mole. What is the mole? So actually mole is amount. Okay, so the amount of mass the amount of mass, the amount of mass that contain, the amount of mass that contain so many particles, the amount of mass that contains so many particles or species. Here we should take any word, okay? I mean either particles or species. The amount of mass that contains so many particles, okay? What are the particles? Either atoms, molecules, ions, electrons, protons and neutrons, okay? So these are the particles or species that equal to number of atoms present in 12 grams of carbon 12 isotope, that is considered as a mole, okay? What is mole? Actually mole is amount of mass. Mole is amount of mass. That amount of mass contains so many particles. That number of particles must be equal to the number of atoms present in 12 grams of carbon 12 isotope, that is called as mole. Are you understood? Okay, that means 12 grams of carbon contains x number of carbon atoms, okay? If some amount of mass is given to us, okay, that mass must contain x number of atoms or x number of molecules or x number of ions. That much amount of mass that much amount of mass of substance is called as mole. Understood? So here the mass of one carbon 12 isotope or atom equal to 1.992648 into 10 to the power of minus 23 grams. Understood? The mass of 1 carbon 12 isotope is equal to 1.992648 into 10 to the power of minus 24 grams. That means 1.992648 into 10 to the power of minus 23 grams of carbon 12 contains one carbon atom, one carbon 12 atom. Now 1 gram of carbon 12 contains x amount of, I mean here x means contains 1 by 1.992648 into 10 to the power of minus 23 atoms. Now 12 grams of carbon 12 contains 12 divided by 1.992648 into 10 to the power of minus 23 atoms. Understood? That equal to now 12 grams of carbon 12 contains 1 by 1.992648 into 10 to the power of minus 23 into 12 atoms, that equal to 6.022 into 10 to the power of minus 23 atoms. So 12 grams of carbon 12 isotope has 6.022 into 10 to the power of minus 23 carbon 12 atoms. Okay, carbon 12 atoms. This number is called as Avogadro's number. This number is called as Avogadro's number. So here 12 grams of carbon 12 is considered as 1 mole. That means 12 grams of carbon 12 is nothing but of 1 mole. Okay, 1 mole of carbon 12 has 6.022 into 10 power 23 carbon 12 atoms. Understood? That means here 12 grams is what is 12 grams? 12 grams is the gram atomic mass of carbon. Understood? That means for every atom its gram atomic weight is considered as 1 mole. For every molecule its gram molecular mass or molar mass is considered as 1 mole. 1 mole of any element or any substance contains this number. What is this number? 6.022 into 10 power 23. That is named as Avogadro number of atoms or molecules. Understood, children? Note it fast. Okay, children, we will continue this chapter in next classes. Thank you very much.